Understanding expansion buses. So a system bus is a series of connections between the CPU and the system memory. And also we talked about we have those addressing lines as well, right? An expansion bus connects add-on devices to the computer system. So expansion buses allow you to add more things to the system. An industry standard architecture, ISA, microchannel architecture, MCA, extended industry standard architecture, EISA. So there's different types, and these are some of them. We also have VISA local bus. We have a peripheral component interconnect, PCI, which is kind of a current one today. And we have an accelerated graphics board, an AGP, which is also current today. And then the Institute of Electronics Engineers, IEEE 1394 FireWire, Universal Serial Bus. We have USB. Everything we know about comes today in USB formats, right? So it's still pretty popular today. The version of USB, there are several different versions. We use USB 3.0 today. So the ISA, the Industry Standard Architecture, it's a standard established by IBM, and they had problems with the ISA design. It has a lack of speed and has compatibility problems, so not every one was built the same. The MCA, the Microchannel Architecture, it was proprietary architecture designed by IBM to defend its market position. So they said, we're going to make a microchannel architecture that nobody else can use, which would be a big mistake, right? But was able to self-configure devices. So that's pretty cool because you just put it in there and it configures itself. It was not backwards compatible with ISA, had a 32-bit data path, and it has been long since been discontinued, right? Obviously, because everything has to play nice together today. Extended ISA, so this is what it looks like from the top view. So you have the ISA bus and then the little extended section in the back. And you can see that there's extra pins there, like the cross section. So you're looking at it from this direction on the bus there. So it's significantly different, the EISA bus. So the VISA local bus, the VLB, so what's attached to that? So we have the CPU and cache, which we talked about earlier. We have the memory. That's the two main things. Those guys have to talk all the time, but we need to be able to put stuff in memory and take it out of memory, right? We want to write it to our hard disk. We want to send it to our video monitor, that kind of thing. We talked about we have mapping to the video and the BIOS and everything. So the ISA, EISA, and MCA bus controller. So you have the controller that has to speak all of these different standards. You have a LAN adapter, a local area network adapter, which is huge today. It wasn't back in the day when this class was built, really. We did have networks, but it wasn't as, I mean, it's required today. And then we have graphics controllers, and then we have disk controllers. So there's a lot of stuff going on there, just those few components. So we also have the peripheral component interconnect, the PCI. It overcomes limitations of ISA, EISA, MCA, and VLB. It has become an unofficial industry standard and is still around today. It has significant differences from VLB, and it's been around a long time. There are also differences in PCI versions. It's an evolving technology, so it's still changing just like anything in a computer. It's always, the only thing constant is change. And then we talked about the AGP, the accelerated graphics port. So what is that all about? So we have local texture surface to back buffer. We have a graphics chip, so those are terms specific to graphics. We have a texture 2, so system RAM to local, CPU, chipsets, disk drive, PCI bus, system memory, texture 1 and texture 2. So there's a lot of stuff going on here, all kinds of information to represent the little pixels that you see on the screen and how to map things and abstract them so that they can understand it and talk to it and get a process. It's not simple stuff to understand. Then we have the i1394, which is the FireWire. I'm sure everyone's heard of that. So we interface, it's an interface originally developed by Apple. It has not seen wide adoption. It's a high-speed interface that allows up to 62 devices on a chain. So it's a daisy chain. So you have a fire in, fire out, fire in, fire out. Advantages, you can hot swap. You just unplug it and plug the new one in. You don't have to turn everything off like you would on the PCI bus. You can't unplug a PCI card while the machine's on. Inexpensive connectors, simple cable design, so they're relatively cheap. Direct path to system memory, so it can access the memory directly through a DMA, a direct memory access chip. And it's not presently a widely used standard, although it's still around today, but it's on its way out. And then we have the USB, which dominated, right? So it connects peripherals outside the computer, supports up to 1.5 megabits for asynchronous transfer. Async means that I can upload 2 and download 10. Asynchronous is what most of your cable modems are. It's what your DSL is. You can download faster than you can upload, okay? That's asynchronous. Synchronous means I download at the same speed that I upload. So that means I can send data as fast as I receive it. That's synchronous communication. This is asynchronous. That means one way is going to be faster than the other. And then 12 megabits for isosynchronous transfer. And then it offers the following advantage. Hot swap, you can just unplug and plug it in. Recognition of new devices by the operating system, so the OS has to support it. And there's an ease of adding new devices. You literally just plug them in. If you look at a USB cable, inside you'll see that 2 of the pins are longer than the other ones, like my 2 fingers here are longer than these 2. So you get the power first, so the device spins up, and by the time you've inserted it all the way, it's already ready to communicate. So it's already spun up and started communicating. So the data channels are ready to go.